Yes. Yeah. Before I would like to hand over this session to our expert, sir, I would like to introduce Dr. T. Ramesh, sir. He is an associate professor at the department. Sir did his
Srinivas, your
being mechanical engineer from Madras University in 1995, and he received master's degree in engineering design from Bhartiyar University in 1997. He has obtained doctoral degree from Bhartiyar University in the area of composite materials in 2006. Dr. T. Ramesh sir is presently working as an associate professor in the Department of Mechanical Engineering, National Institute of Technology, Tiruchirappalli, Tamil Nadu. He has got around 24 years total teaching experience, and he has published more than 50 technical papers in international journals. He is also actively involved in research and consultancy projects. His field of research interests are finite element method, MEMS, microsystems, biomaterials, and composite materials. He is a life member of ISTE, Indian Society for Technical Education. He is also a co-author of the book entitled Introduction to Finite Elements in Engineering. So we are so privileged to have Sir with us, and Sir will be taking to take another session. So it is an interactive session. So I request all of you to listen carefully so that you will get very good knowledge, and also you will get very good information. Also, it will be very good for you to in your research work. Now I welcome Dr. C. Ramesh. Over to Ramesh sir. Sir, please.
Yeah, thank you, Dr. Srinivas Rao, for a nice opportunity given to meet the young minds of different parts of our country. Audience, please stop me at any moment when you have any doubt. I don't want to be a monopoly or always talking on a or in front of a computer, but I need a interaction, right? A real interaction of the faculty or the students who have joined it through virtual mode. So before to start today's session, I would like to express my gratitude to Dr. Srinivas Rao and his team for giving me this opportunity to give a expert lecture on this particular program. Thanks for the participants who spent a lot of time in front of the computers or mobile phone, whatever the digital media you have connected with. Thank you. Today's lecture is planned for understanding the recent technology in the digital era, micro electromechanical systems, MEMS. Somebody can brief about the idea of MEMS, what they have crossed in their life. The participants, you please unmute and answer. Anybody can answer that? Have you ever heard this word MEMS? Okay. There is no answer. I just
no, sir. No, sir.
Yeah. Okay. Proceed my presentation from the scratch. So this screen or this title slide shown a few devices which helped us in the fight against COVID-19, right? Maybe temperature sensor or a device like this to understand whether you have affected with the COVID-19 or not. There are many devices functioning based on the concept of MEMS, but we never realized that it is a mechanical device. It's a mechanical device. Hope there are many mechanical engineers joined today's session. Let us have some idea about, or will carry the memories of the mechanical devices functioning in electrical applications that we'll discuss today. So today's speech is arranged in this sequence. Like, we'll have an introduction about the MEMS and the role of MEMS in different sectors like automotive, biomedical, chemical, etc. Apart from that, I'll show you a few case studies. What we have, what we have conducted in the in our laboratory as a case studies. There are 4 case studies I'll be showing you. If time permits, I will also show you the tester, what we have developed in the laboratory, micron tester. Hope I'm audible to everyone.
Yes, sir, audible.
Okay, thank you. So micro grippers, micro cantilevers, micro joining of plastics, and then micron tester. If time permits, I'll show you the facility. So before to start with, so these are all the recently developed facilities in our laboratory. A PCB routing machine with the microelectronic assembly unit, which is capable of producing printed circuit boards for electronic applications. I think without PCB, no electronic devices will be functional, right? So we have a complete assembly unit starting from routing and then embedding of microelectronics, and we have a pick and place robo along with this equipment. And then it is possible here to assemble all the microelectronics on a board. So this is the routing machine which we procured recently for Student Innovation Center of NIT Trichy. Say the next one is a composite material printer. And here it is possible to print micro level devices with a minimum layer thickness of 100 micron. It's a Markforged brand imported from US. It is possible to print polymer matrix composite embedded with different reinforcements like e-glass fiber or a Kevlar or glass fibers, etc. So there are 2 spools available here, right? So one is for what do you call this, base material, that is a matrix material, and the other one is for reinforcement. I'll show you a few printed components in the later part. And we have a shining 3D scanner in order to capture the 3D image of the object, especially for biomedical applications. So whatever the component we have here, that will be scanned and generated as a cloud point. So from which it is possible to develop any 3D modeling or 3D models, right? So this is procured for developing components with intricate shape. But I'll show you. I'll give a small demonstration tomorrow on this particular device. Also, we are installed with the Mimix biomedical imaging software, which is a imaging software to convert any scanned images into a 3D model. It may be of data collected through CT scan or MRI scan or even X-ray. So that could be developed or that could be converted into a 3D model. And also we have facilities like IntelliSuite software for MEMS solutions. It is possible to develop virtual models of MEMS devices, test it, that is experiment, not experiment, but virtually test it to understand the performance of MEMS devices. It's a very good facility available in our institute. So apart from that, we have many equipments like a CO2 laser cutting machine we have that I'll show you if possible today or tomorrow. Some demonstration I'll show you. Okay. Now, the question is, see, as a mechanical engineer, is it relevant to me for learning this topic like MEMS? Is there any research scopes really available for a mechanical engineer to progress their research in that particular direction? The answer is yes. Not only yes, sure, you have many opportunities. You can work in this particular domain. Then let us have some idea about what is MEMS. MEMS is a acronym of micro electromechanical systems, which represent very important class of systems having applications ranging from small embedded sensors and actuators, passive components in RF, and microwave fields, and micro mirrors in the optical range. I think these words are very new to the engineers, mechanical engineers who attend this program. Am I right? So what Sir is saying? Sensor is using the word like sensor, actuator, passive components in RF, and the microwave fields, etc. But it really takes only very short period to understand what is what. Also, you can correlate with the mechanical principles, what you learn throughout your career, that can be implemented over here in order to understand or in order to develop mathematical models for such kind of MEMS applications. So the word says that micro electromechanical system, the first word, micro, mentions that or defined that the dimensional spectrum on which you are going to work. It is in terms of micron, right? It is in terms of micron. And we have remaining two words like electromechanical. It's a combination of electrical and mechanical. Electrical and mechanical. Means that a mechanical device or a part is employed in a system to generate electrical output in terms of micro values. Since it is an electrical signal, so the output may be in the form of voltage, right? It is able to generate micro to macro level of voltages. That depends what kind of system you are developing. Okay. So what is the importance of MEMS? When I see their advantages, there are many advantages to talk about. I think we'll later in the later part of the presentation, we'll see what are the advantages. But among which I need to highlight these two important advantages. For selecting MEMS as a carrier for any mechanical engineers. The first advantage I want to find here is, or to tell here is, their size. It is a compact size, amenable to integrate with other components. That is very important. The size is very small. So it is also suits with other components, well suited with other components. That is the greatest advantages I will see from other advantages of using MEMS. And then low loss and parameter variability. So as the size is very small, the loss produced by this particular device is very small. Also, it has a parameter variability. You can have, or you can play with the number of parameters. I think you'll be seeing or feeling that how the parameter variability is in the later part of your presentation. So as I was mentioned that the dimensional spectrum where this particular technology suits is in the micro level. Just see, MEMS is falling between the dimensional spectrum ranging from few nanometers to few micrometers or to few millimeters. See here, the size of the virus is few nanometers. Red blood cell in terms of few micrometers. The human hair, whose diameter is roughly 60 micrometer or around 60 micrometer. And now I need to develop a technology which is falling in this category. So MEMS falls under the dimensional spectrum ranging from 100 nanometers to few millimeters. Below which it is called nanotechnology, and above which it is called mesoscale. Am I right? Mesoscale. And then beyond which it is macro applications or macro technology. Now you just think about the size I was mentioned here. It is very small. Means that the entire device may be in the dimensional spectrum ranging from few nanometers to few millimeters. So within which I have parameter variability, and also I found the losses are very, very small. Able to follow me? So any engineering system that performs electrical and mechanical functions with the components in micrometers is MEMS. So these are all the MEMS available products, starting from microsensors. Normally, you found the application of microsensors in biomedical field, chemical, pressure, radiation, thermal, etc. And we have other products like micro actuators, like valves, pumps, grippers, tweezers and tongs, etc. Read and write heads in computer storage system, inkjet printer heads, micro device components like mini robots and toys, microsurgical applications or microsurgical components, etc. Now one can raise a question like, when these particular applications are belonging to electrical or mechanical or biomedical or chemical, so what is the role of mechanical units? See, the functionality of any device is adapting the mechanical actuation or mechanical variation. A biomedical sensor will sense the information about changes in the environment, and that changes is completely measured by means of mechanical displacement. That displacement produces necessary electricity, so that the changes in the environment is completely monitored by means of MEMS device. I'll give a simple example. You are traveling on a car, and you assume the car is installed with the automatic cooling system or air conditioning system. Now, there is a device which monitors the inside or a cabin comfort conditions always, unknowingly. So you don't know that, you will be monitored, your environment will be monitored. If there is any change in the environment, then the necessary device will produce electrical signal in order to actuate the necessary valves, either to open or close, by which it will supply the additional air, or it will stop supplying of cooling or chilly air into the cable. Able to follow me?
Yes, sir.
Yeah. And so before seeing the pictures, I would like to show you the read and write heads in the computer storage system. I think many of you have never seen the internal details of a hard disk, right? Say this is the space available where you write your data, right? So this is coated with a nickel chrome coating, and the disk is capable of running at a very high velocity, like 3,000 to 5,000 RPM. When you see the details of hard disk, you may be finding that what is the RPM, right? Now, this disk is supported by means of this air bearing, right? So signal will be given to rotate this device. And there is a small hanger-like structure which is capable of oscillating like this, so that it will trace the track where the data are. You can find that there is a small tip. You're able to see it, a small tip. That is called a stylus, which has a contact with this particular surface. So it finds where the holes are and where all the data are in the form of holes and non-holes. Am I right? So it will capture the information from this surface. Now, the space between or the gap between this stylus and the surface shall be maintained in nano level. So it is completely controlled by means of this static motor, electrostatic motor, and there are signals given to this system through this wire, right? So it's a micro level or micro dimensional wire which carries the potential or electrical information to this arm. So at this end, I think I'll show you a little closer. Now, this particular stylus is held by means of a small device, MEMS device called micro gripper. Now, the responsibility of the micro gripper is to hold the stylus always. And whenever you want to dismantle or detach, electrical signal will be given due to the temperature or any other system or any actuation system installed over here will make the stylus to detach, right? So this is the way how it is taking the data from the surface or from the track, from the particular track. Now, why I told that it is a electrostatic motor, you can find that this gap, it is like array, right? There are air gaps maintained between the disk and the arm, right? Now, the rotation of the disk also controlled by means of electrostatic potential, which was developed over here. So on the backside of the hard disk, you can find number of microelectronics. So this is a PCB board, right? This is a PCB board. over which there are many devices, electronic devices are embedded. Correct. This is a chip, another control unit, memory unit, everything is installed over here. And when you see the connection, how it is given, you can find that it is very thin. It is in terms of micron, right? The signals will be carried through this road, and it will deliver to the entire PCB board through this circuit. Understand? So grippers, as I was shown, like it has many applications. One of the application is holding the stylus in the read and write heads of the computer storage system. Okay, let us have a discussion on the application of many micro devices readily available or already developed by the researchers, which was shown in the bottom portion of the slide. So this is the first one. The left one is called micro B, which is attached with feathers. Am I right? Feathers. Now the size of the B is completely compared with the size of the coin. Now, what for such kind of devices are developed? Now, recently one attack was done by US Army with the help of such kind of micro robots. It will fly in the sky just by flapping these wings, and the movement will be completely controlled from the ground. Now it deliver or fire the bullets against a person. Am I right? I think I don't want to tell the names and all. He was killed by means of using such kind of technology. Am I right? Now the thing is, so such kind of devices are flying near the borders, and it is completely developed for surveillance purpose for military applications. Now, it has a mechanism, normally called a flapping wing mechanism, to develop necessary lift forces so that the complete machine or the device is flying in the sky. Now, to operate these wings, we require an energy system, right? A micro motor needs to be installed. Once you have a micro motor, then it requires electrical energy. So there are fuel cells integrated into this particular device. Since it is used in a surveillance application, it requires a micro camera. And once it captures the information, it has to send to the ground or the control unit. So it requires a transmission system also, a wireless transmission system also. You just think about, say, how many devices are integrated over here on this small dimensional spectrum. So this is the beauty of micro-electromechanical system. It's a very good example for. So it was developed by MIT, US, for military surveillance applications. So this is the zoomed view of the micro gripper employed in the hard disk, and this is the micro gripper portion of the micro gripper. When electrical supply is given due to the electrical potential difference, this complete device will get heated up, or differential heat will be developed. So because of the differential heating, there are difference in thermal expansion, and due to the expansion of the material, the jaw, which is used for holding any micro devices or nano sized components to move further away, further or away from each other, That depends what kind of application you want. Am I right? So such kind of devices are normally found during surgical work by the doctors, so that the nerves which disturb the location of interest is moved away by means of this particular device. So this is the smallest footprint microflow air pressure sensor developed, and the size is compared with the tip of the pencil. Right. So this is one such device available in every airport. We are unknowingly scanned by this particular device. This is called a explosive direction sensor, sensing device. If you carry any unwanted materials or a chemical along with you, even a picogram of size or a value, this device will sense and give a alarming signal to the security. This device is completely work based on a recent technology called eNose, electronic nose, and one such device was developed by Dr. Ramkumar Rao, Professor IIT Bombay. Now he's a director of IIT Bombay, IIT Delhi. Right. I attended a program he has organized on eNose technology. It was very wonderful. We have seen how this particular machine is functioning. It is completely a mechanical device, developing mechanical functionalities, and producing electrical signal. So this is a what you call this, a boron chip. There are many functionalities are integrated on a single chip. Like it is capable of sensing temperature, humidity, pressure, any chemical variation in the atmosphere. So all these things can be measured by this particular device, all in one chip. So just by seeing, we have many applications found in the day-to-day life, but we are using it, using those technologies without knowing that it is belonging to men's category. Okay, let us move faster. I think the time is. Micro electromechanical systems, or MEMS, is a technology that in its most general form can be devised as miniaturized mechanical and electromechanical elements. So I was shown the micro gripper available in the hard disk. The size is, the thickness of the micro gripper is few microns, right? Now, the mechanical functionality is not miniaturized, but the size is miniaturized. Am I right or not? So when you work with, or when you want to develop such kind of miniaturized mechanical devices, then the conventional equipments, what available or what we have come across, were not suitable or were not adaptable. So that we need to find a new technique, normally called microfabrication. Those techniques are employed for developing such kind of miniaturized mechanical devices. Any doubt? Any questions from audience? Okay. So the dimension, the critical physical dimensions of MEMS devices can vary from well below 1 micron on the lower end of the dimensional spectrum all the way to several millimeters. So the types of MEMS devices can vary from relatively simple structures having no moving elements to extremely complex electromechanical systems with multiple moving elements under the control of integrated microelectronics. Now, the responsibility of the microelectronics are to control the mechanical devices integrated on your system. The one main criterion of MEMS is that there are at least some elements having some sort of mechanical functionality, whether or not these elements can move. Unless otherwise, we don't call such a system as MEMS, it is electronic system. Unless we have a mechanical functionality, how we claim that it is belonging to mechanical category or mechanical domain. So the term used to define MEMS varies in different parts of the world. In the United States, they are predominantly called MEMS, while in some other parts of the world, they are called microsystems technology or micro machinery devices. As we are following US, we always use the terms called MEMS. So micro-electromechanical system is a process technology used to create tiny integrated devices or systems that combine mechanical and electrical components. They are fabricated using the IC batch processing techniques and can range in size from few micrometers to millimeters. So these devices have the ability to sense, control, and actuate on the micro scale and generate effects on the macro scale. That is what I told you, that it is capable of producing microvolt or millivolt or even volt directly. It depends what kind of devices we are using. As this point highlights that any devices, MEMS devices have the ability to sense. It is capable of sensing the changes in the environment, and it is capable of, or it is able to control the changes in the environment, and also it is possible to, or it has an ability to actuate on the micro scale. So MEMS consists of mechanical microstructures, microsensors, microactuators, and the microelectronics, all integrated onto the same silicon chip. And it is illustrated over here. MEMS is the integral part of, or MEMS is the integration of all these four elements. It starts from microsensors, microactuators, microstructures, and microelectronics. Now, as an example, the functionality of microsensor is to detect changes in the system environment by measuring mechanical, thermal, magnetic, chemical, or electromagnetic information or phenomena. I have quoted an example as traveling inside a air-conditioned car. Am I right? Air-conditioned car. Now, a mechanical device which is integrated or which is available inside the MEMS package will be able to sense the changes in the environment. Say, for example, the car is traveling with 2 passengers. After some time, 3 more passengers are getting to the cabin. What happened? So, due to the temperature of the human body, 3 more persons added into the car cabin, the inside temperature of air will get reduced, or there is a change. There is a change in the environment. Am I right? Now, the mechanical device which is available in the MEMS package will be able to sense that, oh, there is a change in the temperature. Now, because the changes in the temperature, what will happen is it will produce mechanical deflection, or mechanical rotation, or mechanical acceleration, whatever it is. Now, because of the displacement produced due to changes in the temperature, that deflection makes a system to generate electrical output. Now, that electrical output will be sent to microelectronic system for processing. It will compare the parameter what we set already for the comfortness of the air. Say for example, 22 degrees centigrade. For that, what is the electrical value? If it exceeds, or if there is a change in the electrical voltage, the microelectronic process understand that it requires some actuation or adjustment in the environment. So what will happen is it will send a signal to the micro actuator. This micro actuator actuate once again the mechanical devices available in the system, so that it will adjust the flow of air or temperature of air which is being circulated into the cabin, or it will stop. So whatever the functionality, that depends what electrical signal given to the micro actuators. It will actuate the necessary devices in order to make the system come to equilibrium condition or normal condition. Now all these micro sensors, micro actuators, and microelectronics are supported on microstructures. Right? So MEMS devices are very small. Their components are usually in microscopic scale. These are all examples like levers, gears, pistons, as well as motors, and even steam engines have all been fabricated by MEMS. So, however, MEMS is not just about the miniaturization of mechanical components or making things out of silicon. So, MEMS is a manufacturing technology, a paradigm for designing and creating complex mechanical devices, system, as well as their integrated electronics using batch fabrication techniques. So, these are all few examples of MEMS devices. There, say for an example, this is a what do you call this? A motor, micro motor. The size is compared with human hair. This length is equal to 50 micron, right? So this length is approximately 60 micrometer. So the size is completely measured by means of or with reference to human hair. It's a gear pair assembly, or gear train, and the size is compared with the legs of mite. Say this is a micro turbine capable of running at 30 to 40,000 RPM. 30 to 40,000 RPM. I think I'll show you one such device we fabricated in our. So this is one such micro device fabricated from acrylic sheet. Is it fine? So the thickness is 50 micrometer, and this diameter is 2 mm, and this hub diameter is 5 millimeter, and then the total diameter or the extreme out diameter is 14 mm, 14 millimeter. But when you see the thickness, it is 50 micrometer. All right. So this is a micro cantilever. when I give a force, it will bend, right? It will bend. I'll show you how this is working in the later part of the slide. Many attempts we made in fabricating the device. We failed. Finally, we got. So this one is successfully fabricated. So when I see the timeline of the major events happened, the history of MEMS development, Feynman was the first scientist who given a large information about micro level components in later part of 1950. And a pressure sensor was developed by Honeywell after 1970, and silicon was identified as a mechanical material by Peterson in the year 1982. And there are many devices developed, like starting from micromotor around 1988, polysilicon micromotor by Toy Muller, and comp drive was introduced in 1989. IR images are developed by Honeywell in the year 1990. Accelerometer was evolved after 1990. And so likewise, we have grown in an exponential way towards 2021. Now we are living the era of MEMS application in biological or human living beings, bio-MEMS. So after 2001 or 2, bio-MEMS was used. So this is the components of MEMS, as I was mentioned, that it's a combination of all these four, like microsensors, microactuators, microelectronics, and microstructures. And this is one such microsensor. We'll just see how it is functioning. I think we have very limited time, so I just want to make this. So this is one such actuator. Similarly, acting like our heart pump, am I right? So this is microstructure, and here we have microelectronics. So there are many terminologies new to the mechanical engineers, but the meaning is very, very common. A transducer is a terminology used by a MEMS designer, which is a device that transforms one form of signal or energy into another form. Here, the term transducer can therefore be used to include both sensors and actuators, and is the most generic and widely used terms in MEMS. So transducer is a combination of both sensor and actuator, since it transforms one form of signal or energy into another form. A sensor is a device that measures information from a surrounding environment and provides an electrical output signal. So in response to the parameter it is measured, whatever the response or whatever the parameter it measures, but it has to produce, or it should produce electrical output. So over the years, this information or the phenomenon has been categorized in terms of the type of energy domains but MEMS devices generally overlap several domains or do not even belong in any one of the categories. So that is why it is not being claimed by electrical people that MEMS is belonging to electrical, or I cannot claim that as a mechanical engineer, MEMS is belonging to mechanical category, or chemical people cannot claim that it is belonging to chemical category. It's a interdisciplinary domain where everyone is required to do their job in a better way. Now the energy domains, as I was mentioned, that it is an overlap of several domains. So like mechanical, thermal, chemical, radiant, magnetic, electrical. There are different domains discussed over here. Suppose a MEMS device or a sensor available in a mechanical field is capable of responding to the parameters like force, pressure, velocity, acceleration, and position. Or it is belonging to thermal, it has to give a response to the parameter like temperature, entropy, heat flow. If it is belonging to chemical category, and the sensor should capable of responding to the concentration of chemical, composition of chemical, reaction rate. And if it is belonging to radiant, then electromagnetic wave intensity, phase, wavelength, polarization reflectance, refractive index, transmittance, etc. And if the domain is falling in the category of magnetic, then it should give a response to the parameters like field intensity, flux density, magnetic moment, permeability, etc. Similarly, if it is belonging to electrical domain, it should be capable of responding to the parameter like voltage, current, charge, resistance, capacitance, polarization, etc. Now, a sensor, as we know that it's a device which measures the information from the surrounding. The surrounding may be of mechanical or thermal or chemical or radiant or magnetic or electrical, but it provides an electrical output signal, right? Then what is the actuator? Actuator is a device that converts an electrical signal into an action. The action may be of anything. It may be of displacement or rotation or any mechanical functionality, any mechanical acceleration or any mechanical functionality. So it can create force to manipulate itself. There is one such a task of an actuator. It can create a force. So once it receives an electrical signal, now the actuator capable of creating new force to manipulate itself, other mechanical devices, or the surrounding environment to perform some useful function. So now these two, the integration of sensor and actuator, we call it as transducer. To understand further, the sensor is supposed to have two major properties, like it should have or it should provide a maximum response to whatever it is to be detected. In other words, it should have large sensitivity. On the other side, it should have very limited cross sensitivity. Suppose a device is developed for predicting the changes in the environmental temperature, or a humidity. It should not respond to other parameters like pressure, air pressure, or force. So the cross sensitivity should be very, very minimal or very small, or it should be developed for selective purposes or it should have a response to highly selective. So this is explained with a simple example like input may be of any form. It may be of mechanical or optical or magnetic or thermal. A sensor convert the input parameters through microelectronics assembly. So signal conversion is happening over here, and then it will give an output as voltage. To clear further, so what we need to have inside the sensor is some kind of detector coupled to something that produces an electrical signal. Is there any material available in such a or to do such a duty? Yes, of course. So here's an example. Like there is a small cantilever. There is a small cantilever made of any material, and is supported on a silicon substrate, over which another material is coated, and then this cantilever is subjected to external influences. Suppose I'm applying a small force here. What will happen is, so because of the elastic nature of the cantilever, this cantilever beam will get deflected, right? Once it is deflected, the material which is coated over the surface of the cantilever or the top surface of the cantilever will get stretched, right? The length of the surface will get stretched. Now, there are certain materials which is capable of producing electrical signal once it is undergone mechanical disturbances or deflection or rotation or otherwise. So here, this red material is capable of converting the deflection of the cantilever into an electrical output. Examples are piezoresistive effect, piezoelectric effect. Suppose I want to use piezoelectric effect, then I will be coating the quartz material or PZT on the top layer of the cantilever. Now, the electrical output is captured from the material, and that will be processed through microelectronics. When the cantilever is in the equilibrium position, no volt will be generated. Am I right? When it is stretched in the downward direction, it will produce some electrical potential. So that will be measured. And now, based on the amount of deflection, it will be already mapped with the electrical values, electrical potential, voltage. It is quite interesting, right? Or it may be of measuring the capacitance of the medium available. Say, for example, the same cantilever is introduced between any two sense electrodes. Now, the gap will be filled by means of any medium. When this particular cantilever is disturbed from its equilibrium position, either down or up, or the bottom, the downward direction or upward direction, the capacitance of this particular fluid will get changed, right? So that particular changes the capacitance will be measured or will be captured and processed further for understanding that what is the displacement happening over here. Very similarly, we have another kind of electrical generation like magnetic and inductive sensing, which is possible if one uses a ferromagnetic material like nickel on the cantilever. But this is not a method easily implemented in assignments. However, optical methods might be used as in any atomic force microscope, but once more, not easily in silicon MEMS technology. Thermal transfer, in contrast, might be used with the silicon MEMS, but not so much for detecting deflections of beams and membranes. So there are many MEMS sensors available in the market, like accelerometers, inertial measurement units, or IMU, magnetometer, or pressure and inertial sensor, pressure sensor, airflow sensor, fuel sensor, impact and crash sensor, MEMS microphone, temperature sensor, and so on. Their application is also listed over here. For example, the pressure sensor is always used in understanding the pressure of air and is being applied in the tire pressure monitoring system. Flow sensor are required to measure the rate of change of the rate and the direction of liquid and gas flows in various applications, including determination of flow patterns, measurement of wall shear stress, viscosity, and density measurements. So these are all few examples where the MEMS flow sensors are installed. So this particular sensor is completely helped in COVID situation, MEMS flow sensor, for understanding the or for measuring the human breath pressure. Right? So this is one such development highly used in COVID situation. Or it is a blood flow monitoring, etc. So to move further, like some analytical input produces an action. To understand further about the actuation being available in the MEMS. So of course, the action might be the production of magnetic field, light, or some heat, but usually it is mechanical movement. So this can be induced by producing a force that pulls or pushes at something directly, or by just producing some pressure that acts on all surfaces the same. So the MEMS actuators are a type of micro electromechanical system that converts energy into motion. The motion may be, or the energy may be in the form of electrostatic or thermal or piezoelectric or magnetic. So this is one such list of applications. Say for example, electrostatic actuators are available in the form of a thumb drive, a scratch drive, a parallel plate inch form, distributed, or a repulsive force, curved electrode, electrostatic relay, etc. Piezoelectric uses BIMOF or BIMOF expansion as a technology for producing the necessary actuation. Thermal, once again, we use BIMOF, solid expansion, topology optimized, shape memory alloy, fluid expansion, state change, thermal relay. And then the magnetic part, we have electromagnetic actuation or magnetostrictive, external fluid field, magnetic relay, etc. So this is one such microassembly unit for micro actuation. Acts like a leg. You just see the expansion and contraction of these two BIMOF legs. Now this is capable of producing a linear motion or linear movement of a small device in a particular direction. So this is a substrate, and we have a piezoelectric layer, and so this is a passive layer, and we have mechanical contact area, and then this is a track. So this is a micro machines deformable mirror used in a LED display unit, developed by Boston. So to brief about the advantages of MEMS, there are the list is lengthy, but I have confined it with only a few advantages. The manufacturing of MEMS is semiconductor IC manufacturing, like low-cost mass invention. So consistency is also essential to MEMS devices. The size of sensor subcomponents will be within 1 to 100 micrometers range, as well as the MEMS device size will determine 20 micrometer to a millimeter range. Power consumption is very low. It requires only milliamps or even further microamps for the reduced value. Simple to incorporate into systems or change. The thermal constant is very small, and then can be highly opposed to shock, radiation, and vibration. And then better thermal development tolerance and parallelism. So when I see the applications of MEMS in different domains, I have listed only 5 fields like automotive, electronics, medical, communication, and defense. There are many applications. So for example, the case of electronics, disk drive heads, inkjet printer heads, projection screen televisions, actuator sensors, avionics, pressure sensor, master data storage system, all are MEMS devices only. The case of automotive, it is possible to understand what is the level of fuel and what is the vapor pressure, vapor pressure that can be monitored in the display unit of the pilot. Am I right? The control panel itself will see that what is the level of fuel, what is the tire pressures inside the tires. So everything is monitored within this, or by seeing the control panel. It is possible all because of MEMS devices. So when you see the automotive sector, the exploitation of the development of MEMS is very huge in the case of automotive sectors. There are many MEMS sensors are installed inside your automotive car. So it has a control module called the engine control module (ECM), which requires input from many situations or many locations. It takes input. Say, for example, a camshaft position sensor, knock sensor, vehicle speed, VSS sensor, crankshaft position sensor, throttle position sensor, coolant temperature sensor, exhaust gas recirculation, manifold absolute pressure map, heater oxygen sensor, mass airflow sensor. There are many other. Even the quality of air which is being get into the engine for burning or producing the power stove will be monitored. Will be monitored through MEMS devices. If it understand that the purity of air is not up to the level, then it will recirculate the air. It will divert the flow of air to the air cleaner before entering into the engine system or engine. So these are a few examples of a real-time monitoring of air pressure. You just see on the rim, you are installed with a MEMS device, small device, which is capable of sensing the or capturing the information about the pressure of air inside the tubeless tire. Right? Now, the new cars are installed with the TPMS, a tire pressure monitoring system, which says that what is the pressure of tires installed. So, for example, left front, I have 26, right tire it is 25, and then rear right it is 27. So, likewise, it is now capable of understanding the tire pressure just by sitting inside the cable. Now I've taken a reference from Pintels.com, where an automotive sector is integrated with different kind of sensors. So starting from air pressure sensors, it is installed with the airflow sensors, fluid pressure sensor, fuel injection sensor, force sensor for brakes, a tire pressure monitoring system, and then airbag sensors, seat belt sensor, weight sensor, door side impact sensor, crash sensor, fuel cell sensor, fuel level vapor pressure, NOx, pollution detection sensor, exhaust gas sensor, and then humidity sensor, airbag side impact sensor, oxygen sensor, temperature sensor, inertial navigation sensor, etc. There are, I think, the recent BMW car was installed with nearly 138 different sensors in order to enhance the performance of the car, as well as to improve the comfortness of the passenger. Right? See. So inside the engine, you just see how many sensors are. So for example, say automotive environment that MEMS devices has to operate in, it has to measure the harsh ambient conditions. Makes automotive MEMS packaging much more challenging than that of other consumer electronic products. So these are a few examples. See, the engine compartment. So these are the drawbacks, like formation of salt, high humidity, leakage of brake fluid, transmission fluid, oxides of nitrogen, engine coolant, gasoline, oil. Right? So monitoring of all these things are done by means of MEMS devices. Similarly, wheel and chassis mounted components able to measure the level of salt formation, the humidity value, brake fluid leakages, gasoline oil, water immersion, etc. So if your vehicle has ESP, that is Electronic Stability Program, on board, it provides you with the two other active safety systems. One is anti-lock braking system and traction control system. We know that ABS prevents the wheels from locking during braking, and TCS prevents the wheels from spinning when starting off and accelerating. And HVAC is the heating, ventilating, and air conditioning system. Nowadays, most of the recent cars are available with this facility. Its goal is to provide thermal comfort and acceptable indoor air quality. And also, the recent cars are integrated with the TPMS, that is a tire pressure monitoring system, which is an electronic system designed to monitor the air pressure inside the pneumatic tires on various types of vehicles. So, the TPMS report the real-time tire pressure information to the driver of the vehicle, either via a gauge or a pictogram display or a simple low pressure warning light. That depends what is the price of your car. Right? And there are many applications you can find MEMS devices in the automotive sector. One such thing is airbags deployment system, airbag deployment system. Right? Okay. So this is a way how MEMS devices are working. It's a MEMS accelerometer. A very simple spring mass system. See, here is a mass, and this is a springs, and there are fixed plates and flexible or moving plates. Right? Suppose when your system is in stable condition, this mass will be in a stable position. Right? If it is disturbed, then it will try to oscillate in this particular direction because of the spring mass system arrangement. It acts like a spring, an elastic spring, and this is a mass, right? Since it is moving, since the mass is moving, the plates also will get change its position randomly, rapidly, right? Now, already there is a medium available between the gap between the fixed and the moving plates, right? So because of the movement due to the changes in the mass position, the capacitance will change. Right? Capacitance of medium will change. So that will be measured. So this capacitance C1 and C2 changes in the capacitance is measured. And say this is an important mechanical device employed in cell phone. To understand that even though you rotate your mobile phone, the picture is stable, right? The picture is stable. It is all because of this device called accelerometer. So apart from this, when you see the mobile phones, you'll be appreciated that we are living with wonders. So this is a display unit, and we just find the thickness of individual layers. So this is a LED display unit arranged by means of number of layers. A reflector and a sensor, touch sensor, and then LED panel. So it is like layers, number of layers. Okay. And it acts like a single system. When I touch here, the corresponding location will be pressurized. It will produce the electrical voltage. And that will be sent to the electronic unit through this a small connector. Right? All are made from thin films. So this is a touch sensor. It also takes responsibility of capturing the biometrics image. Right? So it has a small camera, micro camera, to sense your, to take your information. Fine. And this is one such micro camera found in the mobile phones. So we have accelerometers installed. On the backside of battery, you can found that accelerometer. I think I'm not able to get it now. Okay. Right? In olden days, the speakers are having moving elements. Right? So this is one such a small film-like structure. Can you see the movement? Which is capable of producing very good quality of sound. So this is a very thin layer. So when the vibrations are produced here, it will be converted in the form of sounds. Am I right? Very thin film, nano level thickness. Let us see some applications of MEMS in biomedical engineering. So biology and physiology research and the clinical medical care often require small, lightweight, fast response, and easy to operate equipment and processes that can also be mass manufactured at low cost. That is the ideology of any biomedical engineering. The sizes should be very small, lightweight, fast response, and easy to operate equipment and process. Also, it should be manufactured as a mass at the same time with low cost. Now, MEMS products, when incorporated with microelectronics, IC circuits, and the computing blocks, can become small in size, or volume is very small. It consumes low power, and it is processed through online. Online analysis is possible. Very quick response to satisfy the needs of biological research and clinical care. So there are three cases of biomedical applications of MEMS. First one is research in biology, medicine, and pharmacology, or it is for individualized medicine or improved medical care to patients. Now, the MEMS applications are falling in the category of three different applications in the biomedical engineering. For an example, I have a pressure sensor. When I keep near the brain, I am able to sense the magnetic pressure of or pressure of your brain. So cardiac sensor are installed near the chest to understand the response of your heart. Am I right? Muscle activity sensor. There are many sensors available nowadays, and this is one such example. See, because of working in front of computer, so how your eye got strained. It was a research proposal by Boston University by implanting a MEMS device on the retinal portion of your eye. It was conducted with a pig, but affects most of the prostheses. The material used is titanium, hermetically encased electronics assembly to the outer surface of sclera. So these are the schematic illustration images of soft flexible cardiac sensor in a thin elastic enclosure and data transfer to smartphone app. Now you need not to go for any systematic medicinal care, but you'll be systematically monitored through electronic devices. Right? You see here, it's a flexible electronic system which can be weared on your body at any location. It is possible to twist it, bend it, etc. And there are many other applications I want to show. That how MEMS devices are being used in biomedical applications. So one such high-level development is micro robot. Now it acts like a drug delivery system. The robot will be actuated from outside through electromagnetic field. So it will be permitted to flow inside our body and change the location where the drugs are required. Then it receives a signal from outside. It will explore the location so that it will deliver the necessary drugs on the desired location. Micro robots. Another application includes to remove the unwanted particles inside your particles or any unwanted tissues, unwanted growth of any tissue can be done by means of this new remote controlled micro robots, especially in medical surgery. So as I was mentioned, that the micro robots will also help in understanding the location where you required a surgery. What is the condition of unwanted things happening inside your body? So it has installed with a micro camera right? Micro camera. And there is a power source or a light LEDs, so that it will show you the parts inside our body, because there is no lights also available inside, right? So LEDs are produced, and it is completely controlled from outside. It looks like a small capsule. So the patient will be asked to swallow the capsule. So once the patient swallow, then the control of the movement of the capsule will be done from outside. And now the MEMS devices are available in the form of biopatch, in order to understand the variation in the environment. It may be of a skin sensor or any other type of applications it can be used. That depends on which location it is being struck. Say for example, data being gathered depends on where it is placed on the body. Suppose if I stick this biopatch near the chest, it acts like electrocardiography, ECG. If it is stick near the skull, it measures the brain waves. So it acts like an EEC. Or if you stick this device near the forearm, it measures muscle response to stimulation from the nervous system, means that it acts like EMG, right? Now the cost is very, it is inexpensive, versatile and comfortable to wear for the user. So not only MEMS devices are employed in human life, but also it employs or it helps in understanding the wildlife tracking of the animals. There are very good videos available in YouTube. You just have a look on it. They use MEMS devices in order to study the locomotion dynamics of hunting. When the cheetah is in hunting, how the bone structures will behave. So that is completely captured by means of a MEMS device. We'll be seeing many photographs of in the photographs and videos of Discovery Channel, where you'll find a tracking of a life of the birds. Am I right? Or life of the lion, lifestyle of cheetah or deer, whatever it is. So now it is a camera, a small camera, micro camera is installed near this location in order to understand or study how it hunts. Right? So it is completely monitored through remote in order to understand the behavior of animals and their interactions with their environment. Normally we call it as movement ecology, is done by means of MEMS devices. So besides common diagnosis and treatment, the MEMS system can have important application in orthotics and prosthesis. So besides artificial limbs, by incorporating functional electrical simulation and neural control techniques, MEMS may be used in visual prosthesis in the form of hearing aids, cochlear implant, electrical stimulation for pain suppression, diaphragm pacing like heart pacing, and defibrillation, bladder control, epileptic seizure suppression, the hand gripping aid, arm aid, mobility stimulation, muscle building, and many others. Similarly, in the future, artificial organ or organ repair will benefit from implantable MEMS system for monitoring, actuation, and control. I think we'll have a detailed discussion about biomedical engineering in the tomorrow's session. So MEMS in the microphones, I think as I was shown that there are many devices available or make use of MEMS devices. So starting from cell phones, earphones, headsets, handsets, medical field, automotive, IoT, consumer electronics, laptop, notebook, etc., etc. So MEMS is the driving uh, technology in the field of electronics. Now, with the help of the accelerometer, there are large amount of apps have been developed, maybe used to direct. Our apps are available to even measure the acoustics effect of car. Am I right? Inside, it is possible now. Mobile phone, when you install the app to measure the acoustics effect, you can conduct some experiment. Such a good data can be generated when you travel on a car. So there are certain applications where microelectronics are, MEMS are used. So starting from audio pixel micro speaker, we don't have any moving filaments now. There are new technologies, so MEMS technology are possible. Navigation and environment sensing is possible now with the help of mobile phones. New tactile interface is employed in the form of next input soft touch interface, and then thermal imager for with the help of infrared sensing, and then TI temperature sensor versus competing thermocouple sensor, and then we have improved visual experience. Polite MEMS autofocus are possible. A scanning mirror for limb optics, and then many facilities we have here now. We never thought that when mobile phones are introduced in the year of 2000 or later, right? We never think that video conferencing will be possible, or complete education is depending on this particular mobile phones or the digital technology. The role of MEMS is very important in all the case of developments in microelectronics field. So this is what I shown you. So this is a LCD panel or LED panel. So we have a LED housing, back reflector is there, and then light guide, diffuser, and we have a brightness enhancement films, backlight BLU unit. This is what the total assembly we call the BLU unit. Apart from that, we have a touch sensor, etc. On a mobile phone. So these are all other MEMS applications in the microelectronics field. Maybe we have a projector micro display assembly by means of optical transmitting. The biological and medical, so we have a lab-on-chip cell sorter and cell gripper. And the energy side, we have a fuel cell harvester, energy harvesting with the help of MEMS devices, radio frequency analysis, and then pressure sensing for tire sensor, microphone, printer head, etc. And then accelerometer and gyroscope compass with the help of inertia sensing, which is most dominant currently, just by tracing your location. And map is completely working on working with the help of gyroscopes, accelerometers, etc. And there are many other applications already developed with the help of the information received from accelerometer installed in the mobile phones. See, apart from this, MEMS is used in different applications like chemical sensing. This is one such I want to show you, like how a micro cantilever is applied on a particular application. Suppose my intention is to understand or predict whether explosives are present in the atmosphere or not. Now, there is a micro scale cantilever fabricated from a particular material, over which the material which is very affinate to this explosive material is coated. Affinate in the sense, this material is capable of absorbing the explosive vapors or attracting the explosive vapors. Now, when the explosive materials are present in the air, since it is a touch with the air, this material try to attract the vapor particles, right, or explosive particles. So because of the attraction, vapor particles will come and, explosive particles will come and sit on the top layer of the cantilever. Now, the cantilever tends to deflect because of the additional load captured by this micro cantilever. What will happen? This will get stretched. Along with this material, there are other materials also coated, like piezoresistive material or piezoelectric material. So now what will happen is, when this is stretched or deflected, this material also will be stretched along with the piezoelectric material which is embedded over here. Once it is disturbed from its, or once it is strained, it produces electrical potential. So this potential will be measured and manipulated with the help of microelectronics. That yes, this is or the explosive materials are present. Able to follow me? Now, because a material is coated which is capable of attracting the explosive, a particular explosive particle, it will not be reacted to other kind of material. Suppose if the air is available with any other pollution, that will not make any disturbances over here. The cantilever will not get deflected because of those forces. Now, it is not what you call this available in the open atmosphere, but it will be packed. Normally, we call it as electronic packaging. MEMS packaging is another field where you pack the complete electronic system along with the mechanical device, and you supply the necessary input to the. So, chemical sensor. When you see the chemical sensor applications, it is possible to direct the drug and life sciences research. It is employed in food analysis and storage, fragrance and flavor analysis, chemical industry, medical diagnostics, like detection of diseases in breath analysis, agriculture, environmental monitoring, security devices, detection of hazardous and explosive substances, study of chemical reactions. My one question is, how MEMS is used in agriculture? Is it possible to find any applications or any domain for MEMS to involve in the agricultural developments? Yes, of course. There are large amount of MEMS applications are required in the field of agriculture. Say, for example, to study the wettability of or wetness of soil, to predict the ripening period of fruit for harvesting. Yes, of course, there are many applications available. I think one such application I found in the literature, and we also tried one such applications with the help of micro cantilever. So MCL belongs to class of micro electromechanical system device that encompass all those devices produced by microfabrication. It responds to the recognition even by mechanical deformation. As I was mentioned earlier slide, the functionality of micro cantilever is like this. The material used for preparing the micro cantilever is silicon dioxide, and then over which piezoresistive silicon is coated. I will show you one such a device we fabricated in our laboratory, as well as with the help of IIT Hyderabad. We developed a few micro cantilevers. That's how I'll show you. So this is one such cantilever. Thickness is I think it is 50 micrometer. It is made from aluminum foil. So this is another kind of cantilever. I think I'll move close to screen. So that you will find the difference. Yeah. So this is a simple cantilever, a flat rectangular section. But here we have a small fillet we have produced. So you can able to see this. It is not a flat. So this is one such type. The other we have and this is the one which belongs to this. Can you see the fillet over here? By which the deformation is further enhanced, or the sensitivity of this macro cantilever is further enhanced. So this is developed for a particular application. So this is the way how it gets bent and how the selectivity is. I think I'll show you some examples, case studies. First one is a design and development of micro grippers. We have developed a micro gripper of a very small size. Just a minute. So micro gripper is an essential component to manipulate micro parts assembly in a precise way. I think I don't have any time to detail here. I'll show you the way how we developed this particular device. So this is the micro gripper developed for biomedical applications. It is made from SS stainless steel 306L. And we adopt a technology called topology optimization technique in order to arrive the topology of this particular micro gripper. And this is the location where actuation is given. It is given by means of shape memory. Now, I'll show you the gripper which we have fabricated. Yeah, this is one such gripper We fabricated with the help of microwire EDM technique. And this device was developed by students, BTech students from IIIT RGKUT, Andhra. They have come for internship and they developed this particular device. And so these are all the MEMS devices on a silicon substrate. We have a silicon dioxide, silicon oxide layers we have created. Better I'll show you through microscope so that you will be appreciating what is the shape is. Can you see the shape? It was observed under the microscope now. So this is one such device capable of moving out. That is against or normal to the screen. There are number of devices developed over here on this particular location. Yeah. Can you see the pattern now? Yeah, it's very clear. So this is one such device on which how many holes we have made? 1, 2, 3, 4, 5, 5 by 5 holes. So this length is nearly 1 mm by 1 mm, 1 mm by 1 mm, and it was manufactured in IT Hyderabad. With the help of the MEMS fabrication unit found in. So this is the tip of the micro gripper. What we have done. Can you able to see the gap between two jars, right? Yes. So now here there are fillets and there is no joint found here. Right? We used a top-line mechanism techniques over here to develop this topology. So this is the one what I have shown. The gap is not seen over here, right? When it is viewed under microscope, it is possible to see the gap. Okay. So we have developed this facility in order to understand how the actuation of micro grippers are happening. What is the movement of the jaws? We perform the experiments with the help of the available facility in our lab. So the size of the gripper is compared with 5 rupee coin of ours. It was made from stainless steel 316 to fabricate the micro gripper, and the thickness is 1 mm, which was measured through wire cut EDM for the desired shape. So we have conducted experimental analysis also in order to understand So this is another type of gripper we manufacture, and we conducted experiments. And this is the other gripper. Along with the VIT, this has been published. Yeah. So this is another experimental facility we created in our laboratory with the help of vibration speaker. The cost of the speaker is nearly 1,500 or something. With this, we were able to develop an experimental facility. So this is the micro cantilever, which was installed or which was pasted on the top surface of the moving element of the speaker, vibration speaker. The vibrational characteristics of that particular micro cantilever of a glass fiber was performed downloading sine wave audio file from YouTube. So audio signal was given to the vibration speaker. So sine wave audio will be generated over here, so that the necessary movement, then sine wave movement will be happened in the micro cantilever here, and that was observed through microscope. So there are, so this is a comparison between numerical results and experimental one we conducted, and it was published in COMSOL software. So all the three shapes we were able to capture through microscope. I think you will be appreciating by seeing this. So this is a micro cantilever, and subjected to vibration. You'll see the different modes of this cantilever. Yeah. Able to see it, right? The mode shape was clearly understood from, it is very similar to the one what we simulated with the help of ANSYS software. The total expense we spent is nearly 4,000 to 5,000. Within that, we were able to develop an experimental system. And the other case study, what we have done is micro joining with the help of the CO2 laser cutting machine we are available in our laboratory. It is mostly used in microfluidic chip to detect cancer, gas measurement devices, etc. And we use CO2 laser as a material, as a source of heat, and we were able to join polymer transparent as well as opaque polymer. So this is the facility we have, CO2 laser machine. And we conducted numerical results before going for experiment, and we optimized the parameter, what is the power required and what is the velocity or the linear displacement we required for the nozzle movement. So that was initially finalized with the help of COMSOL software, and then we conducted experiments, real experiments on the laser welding machine. It's not laser welding machine, it is a laser cutting machine, but we use it for joining the metals, joining the plastics. So these are all the samples which we joined. You can see that how beautifully the welding is happening. So heat affected zone is very narrow, and it was conducted with a 9 watts laser power and a speed of 0.5 millimeter per second. 0.5 millimeter per second. So apart from this, we have developed uh, one-dimensional stage with the help of cocktail mechanism technology. So when this is pushed by means of providing an actuator here, when it is pushed, this table will make one-dimensional movement like this, either this side or this side, in a very precise way, few microns. So this is one such facility design we have done. And these are all the other type of grippers developed in our laboratory. Shall I take 2 more minutes?
Yeah, yes, sir. Second session is going to start, sir. How much time it will take, sir?
2 or 3 minutes?
Okay, sir. Okay.
Yeah. So we conducted a tensile test on the plastics joint, and we obtained that the maximum shear strength of the weld sample is 3.2 megapascal, and this strength is achieved for the parameters of 8 watt and 0.3 millimeter per second of speed. We found a number of thermal damages are happening during welding, even though it is optimized. So we suggested to have a heat sink made of zinc selenide, so that the weld pool should look like this. So the strength may be enhanced. The tensile strength may be enhanced further once I introduce. It is under process. We are not to publish this work, just for understanding I have given. Also, we fabricated a micro Tesla valve for one directional fluid flow, which will permit only one directional flow. This is the inlet and this is the outlet. It is not possible to change it. And also we found the application of laser welding in microfluidics device. The microfluidic chip, which is a pattern of microchannels molded or engraved, and there are microchannels developed, and we have conducted tests also. When I inject a fluid here, it should come out from here, right? Or when I give a inlet here, it should go out on both the poles. So this was done by my own student, BTech students. We conducted some experiments also. We were able to see the output over here, right? Outlet of fluids, the micro level, micro liter. With this, I would like to thank the organizers of this program for giving me this opportunity. Any queries I'm happy to address. Any doubt, or I have taken too much of time. If it is true, I am sorry.
Yeah, thank you, sir. But it's not much time, but actually very informative and very practical and very interactive type session. If any participant has any kind of doubt related to this particular topic, you please raise your doubts, and sir is there to answer us. And also, if you don't want to ask directly, you can also ask the queries through our chat box also. So sir will be taking another session tomorrow at 10 o'clock. Okay, so tomorrow also you can ask the doubt.